Good morning, ladies and gentlemen of Precalculus. Welcome again to room 15, where?
Learning never ends.
Learning never ends. That's right. Never stops. Stops synonymous, right?
Right.
So she has the versatility of language to make that connection. That's really good.
Correct.
Do I need to tell your English teacher how you get extra credit for?
Yeah, you can email him. You can email him.
It's a him.
I don't know. It's the college one.
Oh, the college. You take TVCC. Okay, maybe. All right, now. What's going to happen? These first couple days, we're going to do some review of things that we didn't actually get to last year. So there are a couple reasons we didn't get to things. One of which, I had family issues with my mother. And there were times I was missing. So we had some things come up last year that kind of got in the way a little bit. So we're going to review just a couple things that, and we're not going to do them fully, but they're really important, I feel, to at least go over briefly.
We're going to do some algebra 2.
Pardon me?
We're going to do some algebra 2.
It's really some more Algebra 2 review stuff. And it's sort of, and we're going to go over this again in Precalculus, but you're going to learn it better if you get another stab at it. So we want to spiral through the material, get everything at it. That's what we want to do. And to our friends from Crandall here, if you've seen this already, you'll have review on this. So that's right. So what we have here is there are different types of functions we went over. One of which is called an exponential function, which is f of x equals a b to the power of x. Now I'm going to say b to the power of, to make this thing up, b to the power of x minus h, I will say, plus what? K. Do you remember seeing that h and k last year?
Yes.
What that looked like? Okay. So this is kind of, I want to go over kind of the anatomy of an exponential function. This thing right here, a, is called our initial value. This b is called the what? It's a word, starts with B, it's called a base. And then the exponent, the power goes up here where the variable is. And this h is going to shift left and right, and the k does what? Shifts
Up and down.
up and down. So what I'm going to do is I'm going to just go ahead and erase this from now and just kind of concentrate on this aspect of it right here.
Do you want us to erase it too?
Or you can just write it to the side. So this will be our independent variable. I just put the h and k because that's what we did last year with all the parent functions. Remember that? H and k. And our friends from Crandall, did you do h and k last year too in Algebra 2? You did, h and k?
Yeah, I think so.
Yeah. And we did that with absolute value functions and quadratic functions and linear functions, rational functions, all that. But we didn't get quite to the exponential one. So this is our basic exponential function. And we're going to go over that. And this one right here, what would you use exponential functions for in real life? Anybody have an idea?
Maybe like the stock market.
Okay, what it is this is the financial world is built on the exponential growth function. Because what happens, your investments have a certain percentage growth rate. And this growth rate in these financial instruments is an exponential function. So that's a real world use, financial world. Anything else you can think of exponential functions are used for?
Interest.
Pardon me?
Probably interest.
Yeah, interest, and that has to do with the financial world. Also, if you go buy a car, there's an exponential decline function called depreciation. If you buy a car that is a little bit older, are you going to pay new car money for that older car?
Negative.
Hopefully not.
No, you're not. Hopefully not, because if you pay new car money for an older car, you don't understand how exponential decline works.
Just uneducated.
Yeah, oil and gas.
Good thing that you drive a Prius, Mr. G.
Yeah, so that Prius that I'm driving, initially when it was new, maybe it was a $20,000 car, but over those many years, the value has gradually declined, the exponential decay function. So understanding that. Also, you have exponential growth functions. You have the musical scale is based on an exponential relationship, for those of you in music. We talked about that in a little bit in Algebra 2 last year. So a lot of real world uses for this. Okay, so that's the basic anatomy of an exponential function. Then you have another type of function. It's called a logarithmic function. I'm going to go ahead and make another page for this. And that is going to be f of x equals, I'm going to go ahead and just say ln x. And then we can go ahead and we can make this x minus h plus k. We could do that too, right? But we're just going to concentrate on the ln x.
Oh, so we don't need that H?
No.
No.
No, okay.
It was
And
just to
what
show
that
you
looks
the-
like, what that looks like, and I think we did, it looks basically like this. That's basically what it looks like. Remember that?
Yeah.
And then I forgot to do that for this one up here. For this one here, do you remember what this one looks like? Well, this one's going to look like this.
The one that we're doing.
That's our exponential growth function. This is our logarithmic function. And they are inverses of each
Can you
other.
go back to the other one real quick?
Go over here to this.
Yeah.
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 That one.
That's an exponential growth function. Exponential decay function is going to go, it's going to go like this.
But we're not doing that right now, right?
That's an exponential decay function in the dotted line. Okay?
So do we need that dotted line too?
No, except that's, yeah, some going is pretty fast.
Okay, we don't need that.
Okay.
So, but these logarithmic and exponential ones are inverses to each other. Okay, what would you use a logarithmic function for?
And in chemistry you use it
You use it in chemistry, that's right.
log? Yep.
Yeah, logarithms.
On the pH of
The
things?
pH scale.
Yep.
And we're going to cover that in precalculus this year. We're going to talk about also Richter scale for earthquake intensity.
You know that?
There's also the magnitude scale for like magnitude of stars, celestial bodies. So that's a logarithmic scale. But basically what it does, it takes numbers that would be just very large or very small
It dumbs them down.
and makes them more accessible.
6.022 times 10 to the negative 23rd.
Yeah, now he's talking about Avogadro's number, which is a very important number in chemistry. So were you a star student in chemistry?
Yes, he
Remember what
was.
that was?
That was.
Wow. So that's Avogadro's number. The number of molecules are in a mole is what that is.
Oh, moles. Gosh, that's stupid. Moles.
Do you remember that?
I try not to remember.
Try not to remember.
It's not very
All right.
very hard.
So anyway, those are some basic things. And so let's talk about, I want to talk about what a basic, we're going to 19, all right. I want to talk about the, do you remember the rules of exponents? Okay, if you have x to the power of a times x to the power of b, what is that going to be?
You just add the A and B and keep your A.
I don't know, somebody died or something. I'm just gonna say that.
Okay, this is called product of powers. That's what that one is called. Okay, does anybody know what this one is? I'm going to put here x to the a. What is this one going to be? It's going to be x to the power of AB?
A times B.
AB, yes. And what rule do we call this? We call this power of power.
Power of product.
Product of powers or product of power of powers. Product of powers, power of powers. So that's a rule of exponents. Okay, I don't know what this is.
No, yeah, Mr. G, it's not.
Let's try to do better. Okay. What if we have x to the power of a divided by x to the power of b? What is that?
That's the quotient of powers.
Okay, he's right about that.
It's gonna be A over B.
It's going to be x to the power of
A over B.
a minus b. Okay, so you subtract. When you have two powers there like that, that's how you do that one. There's another one here. If you have x to the power of negative a, what's that going to be? Well, it's going to be
Negative x.
1 over x to the a. Okay, then if you have 1 over x to the negative b, what is this going to be? Be x to the b. And so these are the rules of negative powers. Okay, and we have one more rule of exponents. It's this one: x to the power of 0 equals what?
0.
No. X to the
X.
power of 0
One.
equals
X.
1.
I said 1.
What did you say?
I did.
1.
Yeah, I need to start for that.
See, let's start for that one. Probably zero. All right, so this is called the zero power rule. So basically, these are the main rules we use of exponents. And what I'm going to do is I'm going to erase these to get ready for fourth period. Can I do that?
You can.
Let me know, is it okay for me to do that? Okay,
It's
I'll do it.
third
Might need to make that race.
period. I don't know where I
This, my computer's working better than it did first and second period. This is a new computer, by the way.
Oh, it's a new?
Well, it's not like brand new, but it's new to me.
Newer.
Did you get a new
Pad on your thing?
No, this is the old same one.
Same
Is that
pad?
still the Moby Depot?
Yeah, still is. Still is.
look after this?
But I got this computer here. I want to get one that had more memory. I do think it works a little better.
Like a terabyte?
Yeah, the size is, it's the memory, it's the
My
free
favorite is the
memory.
Metro Bike.
Solid state or like C drive?
Pardon me?
Sorry, solid state or like C drive?
Didn't understand your question.
Well, that's what I'm asking, like, what is it? Right, a solid state drive versus a C drive?
Well, it has more random access memory is what this has.
That's all.
I heard you have a TikTok.
Yeah, I have a TikTok account. I haven't put anything. I haven't
Mr.
made
G,
any
you have TikTok? No way.
I have a TikTok account. I don't have any videos.
I
on
don't
it.
have any either. It's
Oh
What's it
my
called?
gosh. Please
It's the
help me.
same as the YouTube
Oh,
channel.
can we give you some follows?
It's
Yeah.
the same as the YouTube
Yeah,
channel.
yeah.
I have to have video first before you.
But we can still follow, so then, and I'll turn on your notifications, so then whenever Mr. G posts.
Let me tell you what. I'll tell you what the TikTok channel
You
is.
should do TikTok raps.
Yeah.
Okay, TikTok
G-Dog.
Yes.
Okay, I'll go follow it right now.
G-Dog
Mr. G.
Enterprise.
Bro, following it right this second.
You could really.
Matt, give you.
Kelsey. You could run the entire.
That's my TikTok account. But I don't have any videos yet. I'm going to have like an introduction to class type video here pretty
You
soon.
should post a rapping video.
Mr. Lee, I will. They'll be short. They'll be more short content videos.
Yeah, I heard
Turn
that
on
Mr. Leach is
Mr.
teaching
G.
you about TikTok and you're teaching Mr. Leach about YouTube.
That's the idea, but we didn't have time to do very much yet. It's
Bro,
underway.
Mr. G, you're not gonna believe this. Come here. Will you come look at this? I looked you up on TikTok and somebody had credited you for your YouTube.
Oh, very cool. See?
Look, dude. That's Mr. G on TikTok already.
Oh my gosh, Mr. G, you're already famous.
All right. We're going to help each other. So anyway, that's a good question. I appreciate the class being involved. So that's going to be it. There'll be videos coming to that. So now the next thing we're going to talk about is rules, basic rules of logarithms. And what it is, if you have log of AB, this is going to be equal to log of A, what? Plus log of B.
That'll give you log C.
Okay? So that's kind of the product rule of logarithms. If you have the log of A over B, what's going to be the log of A over B? Well, it's going to be log A minus log B. And there's one more rule of logarithms, and it's this. If you have log of A to the power of B, what is that going to be? Well, it's going to be B log A. And I don't want you to be worried too much about this because we're going to be going over these a lot later on this semester. Kind of going over rules. Yes.
Look at this. When it says users, there's no Mr. G on there. Are you sure that's what the name is? I typed in math, could you cry?
Really?
Yeah.
Yeah, I couldn't find it either, Mr. G.
Okay, maybe I have to post a video first, but that's what it is. I have a TikTok.
You don't have to post a video first.
Welcome to the adventure of Slope Dude.
I found Slope Dude.
You're going to follow him and he'll teach us aspects of slope. This is the course he's taking today. Again, what he says will teach us about slope.
Sound like a wizard of Bible
Right, reasonable.
Mr. G, are we done with notes for today?
And a quarter of
I'm going to eat my cheese
Okay. All right. Okay. So basically, those are three major properties of logarithms. But what happens? A logarithm is a type of exponent, and we talked about the. Did I have you do this today? No, I didn't. The SAT problem today. This is an exponent problem.
Oh yeah, it is.
And so what you have here is and I think we went over this late last year. This one right here, a to the 2/3 power, that's going to be equal to, well, a to the 1/3 power is equal to the cube root of a.
So it's gonna be
A to the 1/3.
A to the 1/3.
D.
Yeah, so our correct answer to this is going to be D, because the squared will be right here, and the radical root will be right here. So D is the right answer.
Wait, Mr. G, can you leave it up there because we have SAT this year, so we're gonna make sure we get all of these written down.
Yeah, that's right. That's a good use of that. Just write it down. Understood. Yeah, I'm gonna tell you about. We're gonna do a few little exercises in changing between logarithms and exponents, and I think we're going to handle that today. And tomorrow, we're going to do some work on circles, and then Wednesday we're probably going to get to chapter 1.2.
Wait, Mr. G.
But when you make me stop to write something down, that's actually not a bad classroom technique. I'll tell you why.
Pretty good.
Why it's helpful, because did I tell you about my student Stephanie, my pre-calculus student Stephanie?
I've heard about Stephanie.
I've never heard of that.
Well, Stephanie, what happened is she was one of these people who would write these notes down, like what Madeline was saying to me about taking notes. She would stop me constantly for writing notes. I took the time. So I saw her a few years later, and she was studying at UNT Dallas. And what are you studying? Oh, I'm getting ready to be a teacher. I think she ended up teaching in elementary school or something like that. I said, well, how was your math? And she was a really good student in my class, but she took pre-calculus, pre-AP. She says, well, I got an A+ in algebra. I said, well, how did you do that? She said, well, I just took the notes I took in your pre-calculus class. I just used those. I got an A+ in college algebra.
That's crazy.
So between that, and also there was a geometry teacher, Mr. King, who she had earlier as well. Between you and Mr. King, all the notes I had, it was easy. I got an A+. It was easy. So these things that we go over in this class, and especially a lot of you, I hope, are going to plan on taking calculus next year. When we go over calculus, that helps you in college because we have the material there, and you just have the guide to being successful in college calculus. So,
Right.
just something to look forward to.
Couldn't do it.
How many of you did see the video I sent out?
Which video?
The one that I said, no, the easiest $10 I ever made.
I saw it.
I
Did
saw.
you see it?
Sure, I saw that.
I saw it.
Did you like that I had your artwork on there?
I did like that.
That was awesome. But but you never know when learning something is going to come in handy. That was the point of it. Okay, we're going to talk about. Let me show you some exercises here. We're getting towards. Yeah, okay. If we have 2 to the power of 5, what is 2 to the power of 5?
2 times 2 times 2 times
32.
Okay, 2 to the power of 5 is I'm going to say is equal to x, and then if we multiply 2 by
2.
itself,
64.
What the?
let's see, to the third power is going to be 8, to the fourth power 16, to the fifth power is 32, right?
You did it so smart.
Yeah, 32.
Smart guy.
Now, what's going to happen is, so this is a basic exponential equation right here. Okay? Now, and so what happens is we can write this in different forms. So 2 to the power of 5 equals 32. Now, let's say, for example, and somebody brought it up, let's say 2 to the power of x equals 60, well, I'll say 128. 2 to the power of x equals 128. What is x?
That's probably a good question.
It was 30.
Is x 7?
Is it 7?
Okay. What happens is we can rewrite this exponential equation as a logarithmic equation. So I'm going to do that. What we're going to say is we're going to say log base 2 of 128 is equal to x. So what it's saying is 2 to the power of what equals 128. 2 to the power of what equals 128. Do you see it's the same thing, but just kind of written in a different order?
Yeah.
You just kind of flip-flop them around.
It's flip-flopped around. And so we're going to do that. So what we have is we have log, oh, we'll do another one. The log, let's do this. 10 to the power of 6 10 to the power of 6 equals what? You should know this. 10 to the power of 6, you should know this.
600.
6,000.
Just kidding.
6,000.
10 to the power of 6, you should know that. Everybody should know this. Should be
Geez,
back-
I've never had a problem like 10 to the 6 before in my
Is it
life.
6 million?
No.
600,000.
600 million.
That's a lot.
1 million? Where's the 6?
It's
There's no-
1 million.
there's no
Charlie,
six.
did you say 1 million?
Yeah.
Yeah, Charlie's right, 1 million.
Charlie two
Wow.
said
Oh yeah,
that.
why am I saying 6?
Charlie 2 said 1 million.
There you go.
Probably didn't know.
Charlie 2. So are you Charlie 1? He's Charlie 2? Okay, Charlie 2.
Oh,
Yes. Okay, that's one you should know. You should also know that 10 to the power of 3 is what?
1,000.
1,000. Thank you.
1,000.
10 to the power of 9 is what?
Euros.
It's higher than a billion.
E-tag.
Oh, heck.
1 billion.
1 billion.
Okay, 10 to the power of 12 is
1 trillion.
1 trillion.
I'm learning so much.
And really, all these you should know. It should be part of your basic mathematical literacy just to know what these are.
It is now.
It is now, yeah.
Like,
But just like in the video, right, the easiest 10 dollars I ever made, you have to learn these things, right?
Right.
Everything has to be learned. All right. So,
are you serious right now?
so anyway, what we have is we have a language we can use, and we use logarithms for that when we don't know what it is. So let me go ahead and just rewrite something down here. We'll say log of 1 Okay, the log of 100,000 equals x. Well, what is x? Well, what we can do is we can change this into a lot of times into an exponential function. We know that log by convention is log base 10. So 10 to the power of x is equal to 100,000. So what power of 10 is 100,000? It's
5.
10 to the power of 5, right? So we have 10 to the power of x equals 10 to the power of 5, so x is equal to 5. So you're going to be able to do these. We're going to be doing these later on. So that's the basic. We're gonna go back and forth between logarithms and logarithmic equations and exponential equations. We're gonna do that later this semester and go into more detail. And we didn't have a chance to cover that at all last semester, or last year in Algebra 2. Charlie, you remember, Charlie 2, Charlie 2, do you remember doing this in Algebra 2 last year in Crandall?
I think I do.
Sierra, do you remember doing this? You barely covered it, yeah. We just kind of, we would have, but we ran out of time at the end of the year. So were you kind of running out of time and covered stuff really fast? Yeah. So that's kind of where we were. But so it's going to be helpful, Sierra, when we go ahead and go over it again. In fact, we're going to go over it again this first semester in more detail, have exercises and all that. And with that, ladies and gentlemen, we're at a pretty good stopping point for today. And we're going to work on circles tomorrow. Did you get, Charlie 2, Sierra, did you do circles in Crandall last year? You didn't?
Imagine being
I don't
held.
You don't remember doing circles? We'll do circles a little bit tomorrow, and then we'll be ready to launch it. Remember, you turn in your assignment, right?
Yes.
We had 2 people who got extra credit, or 3 people who got extra credit for turning in today, right?
Right.
Right.
So the rest of you turn in tomorrow.
Yeah.
It's a great assignment.
Yes, sir. Yes, sir.